Okay, everyone, still on the practice test, we're going to work through the question 2 index law problems here. Again, speed version, not going to go into a whole heap of detail here. So when we multiply thirds, we do the whole number times the whole number. 4 times 3 is 12. And when we multiply with indices, we keep the base and add the powers. I have a feeling I just said thirds instead of indices a second ago. So that would be p to the power of 3 plus 2, and I don't want to write that out because I know that it's just 5. Don't forget that this is a q to the power of 1, so when I add the powers for the q's, I get q to the power of 3. Alright, when I divide, it's the same thing. I divide the whole numbers like normal, so 6 divided by 2 is 3, and I subtract the powers. Don't forget that's m to the power of 1, so 3 take 1 is 2. And 2 take 4 is negative 2. Now, because my question said answer with positive indices, I have to go a little bit further here with this m to the power of negative 2. And you may remember my metaphor from class about saving the negative numbers. And to save the negative numbers, I'm going to move them down either below the vinculum line. This is called the vinculum line. So if it's a negative on the top, I'm going to move it to the bottom. If it's a negative on the bottom, I'm going to move it to the top. So that n would go to the bottom and the power would become positive. That's my final answer. Don't forget that everything in the brackets has to go to the power on the outside. That includes the 5. So 5 squared is 25. And x to the power of 3 to the power of 2. That's when I have a power to a power. When I have a power to a power, I times them. So I need to go 3 times 2. Which again, I'm not going to write it out. It's just 6. Everything inside the brackets must go to the power on the outside of the brackets. So I need a to the power of 4 to the power of 3. Power to a power, we times them. So it becomes a to the power of 12. B to the power of 5 to the power of 3. Power to a power, you times them. 5 times 3 is 15. And c to the power of 1 to the power of 3, you times them, becomes c to the power of 3. And because they're all different bases, I can't go any further. That's my final answer. Question E messed up a few students when we did it in class today. The first thing, I need the 3 to the power of 3. 3 to the power of 3 is 27. And then I need x squared to the power of 3 times the powers becomes x to the power of 6. Y to the power of 3. On my denominator, the 5 is outside the brackets, so it just stays outside the brackets. Negative 3 squared is positive 9. X squared is x squared. Y squared is y squared. And we've got this divide by x to the power of 0. Anything to the power of 0 just equals 1. So it becomes 1. And we've got a 10 times y to the power of 4 on the denominator. Okay, when I divide for fractions, I use the old stay, change, flip method. What does that mean? It means the first fraction stays. And I'm going to do 5 times 9 is 45. The second the sign changes to multiply, and the second fraction flips. Okay, now I multiply my numerators and my denominators, and I get 27x to the power of 6, y to the power of 7, because I added the powers for the y's, and then 45. Oh, I missed the 10 there too. Let's go back a step. 27 times 10 is 270. And then on the denominator, I have 45 x squared, y squared. We can go a little bit further here by dividing. So 270, how many 45s is equal to 6? And then x to the power of 6 divided by x to the power of 2. Subtract the powers for division, becomes x to the power of 4. Y to the power of 7 divided by y to the power of 2. Subtract the powers, becomes y to the power of 5. And that is my final answer. All right, part F. Everything inside the brackets has to go to the power on the outside of the brackets. Let's get rid of those brackets first. A to the minus 5, B to the minus 4, times when we have a power on the outside, a power to a power, we times them. So 2 times -3 is -6. 2 to the power of -3 on the denominator, and a to the power of -3. Don't worry about your negatives till we get to the end. Top line times the top line, bottom line times the bottom line. I get a minus 5, b minus 6 on the top, 2 to the -3, a to the -3, b to the power of -4 on the bottom. Now we're dividing, so we have to subtract the powers. So here I am doing a to the power of -5 minus -3. What was that? -5 minus -3, which is -5 plus 3, which equals -2. So I get an a to the power of -2. I get -6 minus -4, which becomes b to the power of -2. And then this little lonely 2 to the power of -3, it's the only number. It was on the denominator, so I just keep it on the denominator by itself. Except let's write it the correct way, which was 2 to the power of -3. And this was just my workings, so I'll get rid of that so not to confuse you. Okay, nothing else can be simplified. My last step is to rescue my negative powers. If they are a negative, I swap where they lie on the fraction. So the ones on the numerator go to the denominator with a positive power, and the ones on the denominator go to the numerator with a positive power. And because we know that 2 to the power of 3 equals 8, we can write that as a simple numeral. And that is the answer. Okay, that's the end of question 2. Next video for question 3.